Okay, so welcome to 4Keys Private Tuition, 4Keys College of Science Education. So we would like to thank all of you that are coming to the channel, visiting the channel, watching and following through this series. Like and comment and support. Those that are inboxing also suggesting the material that is more helpful to attend and my suggestions. And in the previous video, I had promised we're going to look at more challenging graphs than those linear graphs that we're looking at in the previous video. You can go and check it out. Anonzima quadratic graphs. So teacher tanga nema properties ema quadratic graphs. You should know that they have a shape called a parabola, which is this curved line here. We call it a parabola. So when you look at your equation, y is equal to ax squared plus bx plus c, the x value, the coefficient of x squared, the coefficient of x squared a, when it's greater than 0, or when it's positive, your curve is going to be facing upwards. It's going to be smiling at you. It's going to have a minimum point. It's going to have a minimum point. When your a is less than 0, that is to say when it's negative, it's going to be like this. The parabola is going to be like this. It's going to be a sad face looking at you. And it's going to have a maximum point as opposed to a minimum point here. Another property is that your value ya a, the coefficient of x squared, kana iri small, you're going to have a wider graph. So let's imagine 1 for a, if I say 2, 3, 4, runotanga ita narrow, saka panika inverse proportion apanditika kana value yacho iri small, graph ringe ri wider, kana iri large ringe ri narrower. So that's another property due to the value of a. It has a y-intercept, the point at which it cuts the y-axis. This is the point where x is equal to 0, so you can substitute into your equation kana x is 0, and you get that, you get c, the constant. Remember, ax squared plus bx plus c. So that c value is the value at which your graph is going to cut through the y-axis. You can solve the equation by of course, substituting your 0 for x and solve the equation. You'll get c. Right, so this is the y-intercept. It may have, usually it cuts through the x-axis at 2 points. We can say p and 0, q and 0. So it has 2 solutions. In other words, it has 2 solutions. Second, my solutions are but solving quadratic equations using the graphical method to find the values of x for which the equation is equal to 0, or for which y is equal to 0. And saka ukasolva unowana 2 ma values are x anonzi ma roots. Saka graph rako paranoita cut through the x-axis ndopa ma roots acho, ndopa solution equation yacho. So you can do that by substituting 0 for y, and you can solve the equation. In a line of symmetry, you can slice the curve into 2 equal halves. So that line of symmetry can be found by looking for the x value, which is, you say p plus q. You take the here p and q here and divide by 2. You add those 2 and divide by 2. So let's do a sketch to see these properties at play. So sketch the graph of y is equal to 2x squared plus 5x minus 12. So the first thing is to find the solution, the points at which the graph is going to cut your x-axis. Saka unongoti let y be equal to 0. Kana wadaro unoita se factorization, and kana wakangana kuti to factorize say situation yakadai, go to our factorization video and watch it. Please like it and share with someone else. Saka ukasvika ipapo double bracket method yako ukafactorize, you're going to get 2 solutions. X plus 4 is equal to 0, 2x minus 3 is equal to 0. You solve that, you get x is equal to minus 4, x is equal to 2 over 3, or 1.5. So I need 2 more points at which the graph is going to cut through the x-axis, and you show that on your sketch, minus 4 and 0, and 1,5 and 0. Now, to find the next thing is to find the turning point or the minimum point. Remember that is when this one is positive, you're going to have a minimum point. So how do you find this minimum point? Remember that p plus q divided by 2. So minus 4, we are up now minus 1,5, now plus 1,5, sorry, divided by 2 is our minimum point. So that's minus 1.25. Remember, this is also our line of symmetry. This x value gives us our line of symmetry. Now if you want to find the y coordinate for the minimum point, you take this value and substitute it. So apo tangoita a improper fraction up, right? So tikati susu 1 by 4 plus 1, we get 5/4 minus 5/4. We substitute into this, what do we get? So we get minus 13 and 7/8 for that one. So this is how you would find your minimum point. So you show that on your sketch. Let's show it on the sketch. Minus 1/4 minus 13 and 7/8. Now the next thing is you want to find the y-intercept. So this is where x is equal to 0. So ukatasa pa equation bako, this is the value for c. Remember the coordinates for the y-intercept are 0 and c. So my c is negative what? Square of 100. Or I can simply say let x be equal to 0. I substitute 0 here and I get y is equal to minus 12. Right, so dina 0 none. Na minus 12 and so here is the point 0 and minus 12, and then I draw my line of symmetry, and then the last thing is to just label the graph to show that this is the equation for the graph. So let's do some more examples. Let's plot some more graphs. So these are the most important properties of the graph. Let's look at more examples. So the question here says, on the grid draw the graph with the equation y is equal to x squared plus 2x plus 3 for the x values between minus 4 and 2. Remember, you need a table. So the first thing is to put your table in place. Akapotakapio mama y values, so we need to fill in the missing y values here. So let's do that by substitution. So pesepana x, we are going to substitute the values that are given in the table. So let's begin with what? With minus 4 and minus 4 there, minus 4 there. We evaluate that, we're going to get minus 11. We do that for minus 3, we get 6, minus 2, we get 3, and 1, we get what? 6. So those are the values. The next thing is to plot these carefully on your graph. So tina minus 4 uyo na 11, that's your first point. Then tina minus 3 and what? And 6. So it minus 2 and 3. Minus 1 and 2, 0 and 3, 1 and 6, and then the last one is 2 and 11. Saka kana tadaro, the next thing is to what? The next thing is to join those points. Join those points. Saka na uchi joiner, you don't use a ruler. No, you don't use a ruler. The curve is supposed to be a smooth curve. So what you're supposed to do instead, I don't get all the marks. I should try and put a smooth curve using my free hand. And let's do it. Another example. Let's look at another example. Draw a graph for the values minus 3 to 4. Saka tikatanga with our substitution up. For minus 3 we have the value, so we do minus 2. We get how much? We get 3. 2 minus 1, we do 2, we do 4. So it's just substituting and evaluating. And now that you have a point, you start to plot them through the graph. So in Shidaro, the next thing is to join freehand a smooth curve. And Kadaro plot a graph. Saka, I want you to look for the following in these graphs. I want to challenge you to look for this. Without a minimum point panapa. On the chagrama coordinates a minimum point. Without y-intercept pano. Don't have to draw a line of symmetry. You can practice this on a graph. Plot this graph on a graph paper and practice doing these things. Want to check out 2 more solutions for this equation using the graphical method. So we are going to redo this together in the next video to solve quadratic equations using the graphical method. Remember, my properties is a graph. I unofana ngochikona kumaona. Uyeze tichazingetitsa futhi how to solve quadratic equations using the formula later on in this series. So hang on, there is more coming up. You tell a friend to come and subscribe and share this with others. So I'll meet you in the next video. Enjoy your study.